Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So we're going to continue on the study of the Orthocenter property supplementary. As I marked it here, it's B1, just because for this figure, as you can see, it's already very complex, and I think it's enough that we will talk about 10 conclusions that we can find from this figure, and I think we have maybe 7 or 8 left. If I add all of them together, it's probably a 2-hour video. That's too long, and we will keep the second half in the next video. As you can see, this is a very complex figure, so we start from the simple one and adding lines gradually. Okay, so the problem set is like this. Let H be the orthocenter of non-isosceles triangle ABC. M is a midpoint of BC. D is projection of H on BC. J is midpoint of AH. The circle J is a circle with diameter AH. Circle O is a circumcircle of the triangle ABC. Line MH meets circle O on points A1, A2, and M is in between the A1 and H. Then we have lots of conclusions. So the first thing is that we know we have a circumcircle of the triangle ABC, so we draw the circumcircle first. Okay. This is our circumcircle, and we have the circumcenter O here. We know that the triangle is an isosceles triangle, so we can draw it like this, and we want to find the orthocenter, so we find the altitude on each side. Let's call it D, E, F, and this point is H. We know that the midpoint of BC is M and the midpoint of AH is J. Okay, J is the midpoint of AH and M is the midpoint of BC. So we want to draw the line MH meets the circle O on points A1 and A2. Right, that's a line. It's a circle on A1 and A2. That's a line MH, and M is in between A1 and H, so that's good. The first conclusion is that we want to prove quadrilateral A1CHB is a parallelogram. Okay, so A1CHB is a parallelogram. We connect A1C, we connect A1B. So for this kind of problem, I'll just start with using the properties we already discussed in the previous video, and here we can extend BH. We extend BH on a point. We extend BH meets a circle O on another point. Let's call it P. So we connect the CP here, and we can find the parallel line of the BP that passing through C meets a circumcircle on another point. Let's call it A3, and we connect BA3. right? So we know that CP equals to CH. CP equals to CH, right? That's a property when we extend the BH meets the circumcircle of the triangle ABC. We know that P and H are the symmetrical point of the AC, so we know that CP equals to CH. That's the basic property of the orthocenter. And then we did the parallel line that CA3 is in parallel with BP, right? CA3 is in parallel with BP. That means the CA3BP, this quadrilateral, is formed by a parallel line cutting through the circle O, which means CA3BP is an isosceles trapezoid. So we get that CP equals to A3B, right? And we know that A equals to CH. Also, because CA3BP is an isosceles trapezoid, that means angle CPB equals to angle A3BP, right? This angle equals to this angle. And we already know that P and H are symmetrical to A, so the angle CPH equals to angle CHP. So based on angle CHP equals to angle A3BP, we know that CH is in parallel with A3B. Okay, so CH equals to A3B, and CH is in parallel with A3B. That means CA3BP is a parallelogram. Right, CA3BP is a parallelogram, which means the midpoint of BC is also the midpoint of A3H. Right, M is midpoint of A3H. Then we can think that we got A1 from the intersection point of line MH. And we know that A3 also on the circle O, and A3 MH are collinear as well, which means A3 and A1 are the same point. Are same, right? That is saying CA1BP is a parallelogram. Okay, that's for the first question. And the second question, we want to prove that A1A is diameter of circle O, A1A. So we can connect A1A here. Okay, we want to prove that it's a diameter. Think about angle. Now you can forget about A3, right? Forget about BA3 and CA3. We want to prove that A1A is a diameter, which we can check on the angle A1CA. Because angle A1CB equals to angle HBC, right? Because HCA1B is a parallelogram, so this angle equals to this one. And angle HBC, this one, plus angle C equals to 90 degrees. Plus angle BCA equals to 90 degrees. So we know that the angle A1CB plus angle BCA equals to 90 degrees. A1CB plus angle BCA is 90 degrees, which means the angle A1CA equals to 90 degrees, which means A1A is diameter. Okay, that's question 2. The question 3, we want to prove that A2 is the intersection point of circle O and circle J. Okay. And the line A2H passing through M1 and A1. That's of course right. So we want to prove that A2 is the intersection point of circle O and circle J. We actually get A2 from drawing the line MH that intersects the circle O on this point A2. So now we want to prove that A2 is the intersection point of the circle J and circle O. Basically, we just need to prove that A2 is on the circle J, which means we need to prove that A2, let's connect this. We want to prove that A2 is on the circle J, right? Remember that AA1 is a diameter, which means the angle A1, A2, A is 90 degrees, which means the angle HA2A is 90 degrees, which means A2 is on the circle J. Okay. For the fourth problem, we want to prove that A2DM are cyclic and A1ND are cyclic. N is a midpoint of A2H. Let's check the first part. A2DM are cyclic, right? Because angle MHD equals to angle AHA2, and this is 90 degrees. I mean, this is a right angle, this is a right angle, so we know that the angle DMH equals to angle HA2, right? This one equals to this one, so this one equals to this one. Then we know that A2DM are cyclic. For A1DN, we know that N is a midpoint. For example, here, midpoint of HA2. We want to prove that this one. Let's connect it. Right, we want to prove that A1DN are cyclic. So first think about this one. What is N? What is point N? N is a midpoint of HA2, and D is a projection of H to BC. M is a midpoint of BC. J is a midpoint of AH. That means M, D, N, J are cyclic. They are on the 9-point circle, right? So if we connect MJ and we connect JN, we know that MJND are cyclic, right? On the circle, 9-point circle. That's a property of the 9-point circle. So that means this angle, the angle MND. So we get angle MND equals to angle MJD. And because M is a midpoint of A1H, J is a midpoint of AH, that means MJ is in parallel with A1. Which means the angle MJD equals to angle A1AJ, whatever, A1AD, right? So the angle, this one equals to this one, and this one equals to this one. That means the angle A1AD equals to angle A1ND. So A1DN are cyclic. Okay, that's a fourth problem. The fifth one, we want to prove that OM A2J are cyclic. We want to prove OM A2J are cyclic. So we know that O is a midpoint of AA1, J is a midpoint of AH. So OJ is in parallel with MH, which means OJ is in parallel with A1A, right? And if we connect OM, we know that M is a midpoint of A1H. So we know that OM equals to half of AH, which is JH, right? So OM equals to JH. And JH, because A2 is on the circle J, so JA2 equals to JH equals to OM, right? JA2 equals to JH equals to OM, which means JOMA2 is a southeast trapezoid, which means JOM2 are cyclic. Okay, so the problem 6. We want to prove that BA2 to CA2 equals to CA1 to BA1 equals to cosine B2 cosine C. This is an interesting question. What is cosine B2 cosine C? Right, I just connect this one here, and we want to actually connect BA1, BA2, and CA2. Let me do the connection. BA2 and CA2. So the question is, what is the cosine C? What is the cosine B? Right, because we want to prove that BA2 to CA2 equals to cosine B2 cosine C. Notice that because this is 90 degree, this is 90 degree, so we know that because this is 90 degree and angle EBC plus angle C equals to 90 degree. And because this is 90 degree, the angle EBC plus angle BHD is 90 degree, which means the angle BHD is angle C, right? So write it here, angle BHD equals to angle BCA. Similarly, we can get angle CHD equals to angle CBA. Right, this is angle B. This is angle C. So this is 90 degree. Then cosine angle B is HD to HC. And cosine, let me grab an interpreter. Right, so cosine B equals to, cosine angle B equals to HD to HC, and cosine angle C equals to HD to HB, which means cosine B to cosine C equals to HD to HC to HD to HB, which equals to HB to HC. Right, equals to HB to HC. And basically we want to prove that BA2 to CA2 equals to HB to HC. That's the question. And what is HB to HC? Because the triangle BHF is similar to triangle CHE. So we know that HB to HC equals to BF to CE. right? Equals to BF to CE. And then the question is that can we prove BA2 to CA? So can we prove that BA2 to CA2 equals to BF to CE, right? Look at the figure. We want to prove that BA2 to CA2 equals to BF to CE. So what about connect the FA2 and EA2? Right, we connect FA2 and EA2. If we can prove the triangle A2FB is similar to triangle A2EC, then we can get this one, right? So let's look at the triangle A2FB and triangle A2EC. Because the angle FBA2, the angle FBA2 is the angle ABA2, which is the angle ACA2, which is the angle which equals the angle ACA2 and which is the angle ECA2. Right? So we know that this angle equals to this angle. Now the question is, can we prove that this angle equals to this angle? Right? So remember that we know AFHA2 are cyclic. Right? AFHA2 are cyclic. And because HE is perpendicular to HC, so this is 90 degrees. Right? Which means the angle AHE is a right triangle, which means E is also on the circle J. Right? E is on circle J, which means AFHEA2 are cyclic. And based on this, we know that angle AFA2 equals to angle AEA2. And because angle AFA2 equals to angle AEA2, so 180 degree minus these two, we got angle A2FB. A2FB equals to angle A2EC. So we have this condition. We know that triangle A2FB is similar to triangle A2EC. So we know that these two triangles are similar. And because these two triangles are similar, we get that FB2EC equals to BA2 to CA2, which means BA2 to CA2 equals to cosine B to cosine C. Right? For the question that CA1 to BA1 equals to cosine B to cosine C is very easy because CA1 equals to BH, BA1 equals to CH, and because BH to CH equals to cosine C to cosine B, cosine B to cosine C, then we know it is true. Right? Okay, for the problem 7. I think I have to use this figure. It's easier to look at, right? Problem 7. Let the circle with diameter A1H meet circle O on S. So the circle with a diameter A1H, which centered on point M, right? This circle meets the circle O on point S. That's a circle with diameter A2H. A2H. We use a midpoint N as a center, draw the circle, meet the circle O on point K. And A1S meets A2K on a point T. And then we want to prove that TH is perpendicular to A1, A2. And some other triangles, we want to prove that they are similar. So, because A1S, K, A, these 4 points, actually A2, A1S, K, A2, these 4 points are cyclic. They all on the circle O, right? So we know that TA1 times TS equals to TA2 times TK times TK, right? That means the TA1 times TS is not only the power from T to the circle O, but it's also the power from T to the circle M, which means that T is a point, has the same power to circle M and circle O. And because TK times T2, it's not only the power from T to circle O, but it's also the power of T to circle N. So T is also, and this is equals to TS times TA1. So that means that T has the same power to circle M, to circle O, and to circle N, right? T has the same power to circle M and circle N, means that T is on the radical axis of the circle N and circle M. And because circle N and circle M are tangent on the point H, right? We know that if two circles are tangent, then the radical axis is this tangent line, this common tangent line. That means, and we know that T is on the radical axis of these two circles, which means TH is a radical axis, right? TH is a radical axis. And we already know that A1, A2 passing through the connection of the center. So TH is a tangent line to the circle M and circle N. So TH is perpendicular to A1, A2. Okay. And we want to prove that the right triangle A1K is similar to the right triangle A2HK. And also we want to prove that triangle HA1K is similar to triangle A2AK. Okay. So basically we want to prove that the triangle A1K is similar to triangle A2HK, right? A2HK and A1K. This one is similar to this one. And also we want to prove that triangle HA1K is similar to triangle A2AK. So for the segment pair of the triangles, we know that the triangle HA1K and triangle A2AK, this angle, the angle A2AK, the angle A2AK, reference to the arc A2K, which equals to the angle A2A1K on the circle O, right? So it equals to angle A2A1K. And we already know that angle A1KA equals to angle HKA2 equals to 90 degree, right? This is 90 degree and this is 90 degree. That means angle HKA1 equals to angle A2KA, right? Because this one plus angle AKH equals to 90 degree. And this angle, the angle HKA1 plus angle AKH equals to 90 degrees. So these two angles are equal, which means the triangle A2AK is similar to triangle HA1K. Right, we get this one. And based on this, we know that angle AA2K equals to angle A1HK, right? This angle equals to this one. So we use 180 minus this 2. 180 minus angle AA2K equals to 180 minus angle A1HK. We got angle A2HK. So angle A2HK, right? And 180 minus angle A2K. That is angle A2, and for example, for this one, let's call it Z. It equals to angle A2Z, right? And because A1, K, A2 are cyclic, that means angle A2Z equals to angle A1. This angle, right? This angle equals to the angle, this one, opposite 2. So the angle A2Z equals to angle A1K. Right, that's yeah. So this one, 180 degree minus angle AA2K minus angle AA2K. That is angle AA2Z, which equals to angle AA1K. And we know this one also equals to angle A2HK. So A2HK equals to A1K, and they are all right triangles, which means triangle A1KA is similar to triangle HKA2. Okay, that's for the question 7. And for the question 8, line A2D meets circle O on G. So you can see line A2D meets the circle O on this point G. And AG, we want to prove that AG is a conjugate median of triangle ABC. And also we want to prove that angle A1AM equals to angle DAG. And quadrilateral ABGC is a harmonic quadrilateral. And I make a star sign here. We want to, that's not on the book. It's just, I got this conclusion. We want to prove that angle AA1M is similar to, triangle AA1M is similar to triangle AGD. Okay, let's just look at what we want to do here. We want to prove that angle A1AM equals to angle DAG, angle DAG. AG, right? We want to prove that the angle A1AM equals to angle DAG. So actually, we can prove that triangle A1M is similar to triangle AGD. Okay, so the first thing we notice that the angle A1M is angle A1, A2, which equals to angle AG, A2, which is the angle AGD. So the first thing we get here is that the angle A1M equals to angle A1, A2 equals to angle AG, A2 equals to angle AGD. Right, so this angle equals to this angle. And then let's think about another thing here. Just look at AMDA2. Okay, look at AMDA2. Because angle ADM equals to 90 degrees and angle AA2M equals to 90 degrees. So we know that AA2DM are cyclic, right? This is 90 degrees and AA2M is 90 degrees. So we know that AA2DM are cyclic. Because they are cyclic, so we know that angle AMA2 equals to angle ADA2. Right? Because AMDA2 are cyclic, so the angle AMA2 equals to angle ADA2. And we use 180 minus both, then we got the angle, let's see, 180 degree minus angle AMA2 equals to 180 degree minus angle ADA2. And 180 degree minus angle AMA2, we got angle AMA1, right? So we know that angle AMA1 equals to angle 180 degree minus angle ADA2, we got angle ADG. So we know that angle AMA1 equals to angle ADG. And we already know that this angle, the angle A1M equals to angle AGD. So we know that triangle AA1M is similar to triangle AGD. Right? These two triangles are similar. Which is very, very important. Because when we get these two triangles are similar, we know that the angle A1AM equals to angle GAD. That's one problem set, right? That's one problem set. We want to prove this one. So we just prove. And now we want to prove that AG is actually the conjugate median. I hope you still remember the concept of the conjugate median, which means that AG is a symmetrical line of AM to the angle bisector of angle BAC, which means that we just need to prove that angle BAM equals to angle GAC, right? We just need to prove this. So we already know that angle A1AM equals to angle GAD. So that means if we can prove angle BAA1 equals to angle DAC, then we just prove that AG and AG is a conjugated median, right? So think about BAA1, the angle BAA1. Angle BAA1 is passing through the circumcenter O. So if we connect BO here, we know that angle BOA is twice of angle C. So the angle BAO1 is 180 degree minus angle C, right? 90 degree minus angle C. So angle BAA1 equals to 90 degree minus angle C. And what about angle DAC? Angle DAC, it's obvious it equals to 90 degree minus angle C, right? Because this is 90 degree. So we just prove that angle BAA1 equals to angle DAC, which means the angle, and we know that angle A1AM equals to angle DAG. So the angle GAC equals to angle BAM, which means we proved that AG is a conjugate median. And we still want to prove so for this part we're done, right? And oh no, not yet. And we want to prove that quadrilateral ABGC is a harmonic quadrilateral. So we want to prove ABGC is a harmonic quadrilateral, which means that we want to prove AB times GC equals to BG times AC, right? So remember, we just proved that angle BAM equals to angle GAC, right? The angle BAM equals to angle GAC. And angle AGC equals to angle ABC. Because they all reference to the chord AD. So we know that triangle ABM is similar to triangle AGC. Right, we can have that conclusion. And similarly, we know that angle MAC, the angle MAC equals to angle MAG 加 angle GAC. Angle MAG 加上 angle MAG plus angle GAC. Angle MAG plus angle GAC, that is angle MAC. And it equals to angle MAG plus GAC equals to MAB, right? Angle MAB. So it equals to angle BAG. So we know that angle MAC equals to angle BAG, right? Angle MAC equals to angle BAG. And angle ACB equals to angle AGB. So we know that triangle AMC is similar to triangle ABG. Okay, based on these two, for the first one, we have AB2BM equals to AG2GC. Right, AB2BM equals to AG2GC. And for the second one we have let me look at it, ABBM. So we want to have AB here, and we want to have BG as well. So we have AB to BG equals to AB to BG equals to AM to MC. Right? We can manipulate second one. We got AB to is that correct? AB to BG equals to AM to MC. Right, something wrong here. Oh, I guess we can, it's better not using this one here. Let me rewrite it. So this is true, right? We want to have AB to BM. Then we got AB. So that's true. AB to BM, which equals to AG to GC. AG to GC. Right? Actually, no, let's do this way. Still, for these two, we have AM to BM, right? AM to BM equals to AC to GC. And for the second one, we have AM to CM. AM to CM equals to AB to BG. And because BM equals to CM, AM equals to AM, that means AC to GC equals to AB to BG, which means AC times BG equals to AB times GC. Right? AC times BG equals to CG times AB, which means ABGC is a harmonic quadrilateral. Okay, and the next one, the ninth one, we want to prove that JOMSA2 are cyclic, and S is a symmetrical point from H to BC. So basically, we got S here. It's a symmetrical point from H to BC. We know that S must be on the circle M as well. This is very easy to prove. So we want to prove that JOMSA2, JOMSA2, right? We just proved that A2, JOM are cyclic. And now if we look at JOMS, because JO is half of A1H, which means that JO equals to MH, right? And because OM is in parallel with JS, because they are perpendicular with BC, this one and this one, this is in parallel with this one. And we know that MS equals to MA1 equals to MH, which means MOJS is an isosceles trapezoid, which means these 4 points are cyclic. And because MOJ already can define a circle, so we know that A2JOMS are cyclic. And we still want to prove that AOMG are cyclic. These are the conclusion I find. It's not on the book. So let's see. We want to prove AOMG. AOMG. So we want to prove AOMG are cyclic, right? Let's see. We want to prove AOMG are cyclic. Look at this angle, the angle QMG, This one, basically we want to prove that this angle, let me explain a little bit. So because we already proved that AG is a symmetrical line of AM to the angle bisector of angle BAC, and we know that angle bisector of angle BAC meets angle bisector of angle BAC meets the midpoint of the arc BC, so which is Q here. And we already know that this line and this line are symmetrical. So we know that C and L, we can easily prove that C and L, they are symmetrical on the they are symmetrical to the OM as well, which means this angle equals to this one, and we know that this angle equals to angle OMA, right? And basically we want to prove that angle QMG equals to angle OAG. So the question is, can we prove that angle OMA equals to angle OAG? And because OM is in parallel with AS, so the angle OMA equals to angle MAS, right? This angle equals to angle MAS. Now the question is, can we prove angle MAS equals to angle OAG? Which is obvious because they share the common angle MAG, and angle OAM equals to angle GAS. We just proved that. Okay, that means AOMG are cyclic. And still we want to prove that OM is tangent to the circumcircle of triangle A2MG. We want to prove OM is tangent line of the circumcircle of triangle A2MG, which is easy to do, right? Because look at this angle, we already proved that this one equals to this one equals to this one. And the angle M, the question is that can we prove angle MAG equals to, can we prove angle MA2G equals to angle equals to, so this angle, because we want to say this angle equals to this angle, right? And we just prove that this angle equals to angle MAS, right? MAS. So the question is that can we prove the angle MAS or angle MAD equals to angle MA2G or angle MA2D, which is obvious because we just proved A2DM are cyclic. So we know that this angle equals to this angle, which means OM is a tangent line to the circumcircle of the triangle A2MG. Okay, that's for this video. It's about half of the properties or conclusion we can find about this figure, and we have another half. I'll explain it in the next video. I hope you like this video. I think it's a very fun journey. So see you in next one. Thank you.